I have a mic, I have a clicker, I have a beer. I think we're ready. Hello, and welcome to Developing for Android. So we had an internal meeting at Google a few months ago with some app developers, and one of the questions that came up was, well, we keep hearing when we do certain things on our applications that we shouldn't have done it that way, and instead someone will give us a pointed answer and say, well, obviously you should have done it this way instead, which is nice to know, but wouldn't it be nice if there was actually a place that we could go to learn this information ahead of time instead? We said, yes, that would be nice. It does not exist. So we thought maybe instead of just yelling at them, we could make that thing exist instead. So we wrote this massive article basically for those internal Google developers that we called, in a very clever way, Developing for Android. And then we took that very same article, stripped out the 2% of Google-specific information, and published it online as a series of articles on medium.com, which we then cleverly retitled Developing for Android. So when we wanted to give a presentation tonight, we thought maybe we should give a presentation that we would call Developing for Android. We're really stretching for ideas here. So the idea behind the presentation is basically an overview with maybe a little more anecdotal information and conversation and question and answer around that very same topic, Developing for Android, which is basically the best practices or patterns that mobile developers should really consider when they are writing real applications.
Well, and more precisely, every point we make in this presentation came from an actual issue that we saw at Google in our applications. And maybe we'll share some stories to shame some of our coworkers. I always like doing that. I used to yell at them, now I shame them in public.
So the time that we have for the presentation is somewhat limited. I think we're probably talking for, I don't know, an hour including Q&A, which means that we're probably not going to get through the 10 fairly deep articles worth of information. So I would encourage you to also check out the articles. But you can do that at your leisure, not necessarily while we're talking.
And we are here to help as much as possible. So if you have questions during the presentations, just raise your hand. We can have a discussion about different topics. We don't have to go through everything that's in the slides. So yeah, it's up to you. We're here to answer your questions, basically.
So the subtitle is Avoiding the Tragedy of the Commons. There's two linked problems that we have encountered in the mobile development space in particular. Tragedy of the Commons is closely related to what I also call every device is a village, which is the idea that every application is going to do what's best for it. And if you measure that application, everything that it's doing is probably fine, right?
Not always.
Not always. You know, there are some obvious pitfalls that you can run into where you can, measure that particular application and it's really doing stupid things that are going to show up in a profiler. But what we have seen over time is that even reasonable applications that are doing not too much of that stuff, when added up in the aggregate over an entire device, makes the device, I don't know, what's the word, suck, right?
So yeah,
you put it all together and it tends to suck.
So I have an anecdote about that. So we have this application called News and Weather that ships with Android. And these days it's a really good application, it's beautiful and all that. But back then, when for the first version, there was a widget for your launcher. And if you added the widget on your launcher, it would update the weather and the news every 8 seconds. And so we went to the team, we're like, why are you doing that? Like, it's terrible for the battery, it's terrible for performance, terrible for memory and all that. And they were convinced that people really wanted to see their news updated every 8 seconds. So I don't know who the target audience was. But anyway, we convinced them to change that to something more reasonable. But that's the kind of things that we've encountered a lot. And if you have 150 applications on your phone and everybody does that, it's not going to be good.
Maybe it's the flip side of like the short attention span that we all have thanks to mobile devices and the web, is that we have a short attention span. We also have a really short memory. So in 8 seconds, you're going to need to retell me what the headlines were because I've forgotten. So moving on, that's us. You can reach us or follow us on G+ and Twitter if you have any interest in that. So let's.
You still use G+? I had to, sorry.
Memory. So for most of the items that we'll talk about here, there's some sort of overriding, here are the general concerns. Here's what you need to understand. Actually, my personal favorite part of this series of articles was the first chapter. It was understanding the mobile context, which is basically, here's the stuff that you really need to understand about mobile development that all of the rules apply to, right? And one of the most important is memory. Basically, hey, it's limited. So even though that device that you use has 2 gigs on it, and the device that you had last year had 1, there's still a lot of the world that is using devices that have 512, very limited amounts of memory. Not only that, but they're continuing to sell these devices, which means the people in the rest of the world or in places that aren't particularly Silicon Valley are going to continue to buy and use those devices for years to come. So the necessity of actually paying attention to real memory constraints is unfortunately very real. Beyond that, it's also shared memory, right? So not only does your application need to obey those memory limits, but everybody does, and everybody's running in this shared sandbox. So one of the things that we've seen apps run into is, well, they'll use a lot of that memory, and then they'll be in the background, and the user will go out to launcher, and then they'll run some other application, and eventually the system's going to want more memory because it's out, because all the applications are being really greedy, and it's going to look at your application and say, wow, there's a lot of memory. Why don't I kill that activity, right? So the more memory that you're taking up, the more attractive you look to the system when it needs to actually free up resources for other activities to have.
So can I give you a recent example?
Please.
So I used to wear a Moto 360, and I don't anymore, because the Android Wear application on my phone was taking 150 megs of memory at all times, causing all my other applications to get killed all the time. And I figured that just to get the time, 150 megs was a little much, so I don't wear the watch anymore. And hopefully they will fix that soon.
He said, 150 megs? Not on my watch.
Uh-huh.
I've been waiting for weeks to use that joke. Weeks. Okay, and another important point, this is going to come up later too, is that memory is performance. Given the way the runtime works, both Dalvik as well as Art, when you allocate and when you free objects, that costs performance, right? So when we talk about allocating memory, yes, don't use too much, but also don't allocate and free. Don't cause a lot of temporary allocations because you are costing performance. It's not just about memory. It's about the amount of battery that it's going to use, the amount of cycles it's going to use, and the amount of jank that you're going to introduce in your application because you're causing garbage collections in the middle of actually trying to do stuff.
And it's especially important at startup time for your application, because if your application is memory hungry, chances are it will get killed in the background. Like you go back to launcher or you launch a game or the web browser, something pretty heavy. So if your application gets killed and the user wants to quickly get back to it, so if your application was killed, we have to do a cold start and we have to reinitialize your process, reinitialize your classes. You have to redo all the work that you've already done, and it's not great for the user. And for a lot of apps, it can be annoying. Like if it's Google Maps or if it's a camera application that you really want to see instantly, if the user has to wait for a few more seconds every time because it gets killed constantly, that's really a terrible experience. So it's about helping the others, but it's also about helping the users.
So here are some general tips and practices about allocations.
So to be clear, a lot of those practices are frowned upon on the server side or on the desktop, but we have a good reason to recommend those practices on mobile. So you will find conflicting information about some of those, like object pools, for instance, online. So be always careful when you see that kind of best practices or articles that tell you, how to architecture your application or what performance pattern to use. Make sure that they are targeted for your use case. And again, it will depend greatly on the kind of application you're writing. But we'll talk about it in more details.
I should mention too that a subtitle of this talk or the articles could actually be Android for Java developers. One of the problems that we ran into, one of the reasons that the question came up internally at Google is that we have a lot of very experienced developers using Java or other high-level languages, in particular writing web apps or server-side applications, and they have particular patterns and practices and libraries that they've developed over the years, and this is the way that we write with this particular language. And then they come to a mobile device and they try to apply that same experience and practice into a very constrained environment, and then they hit the wall. So what we're talking about here is not the way to use the Java programming language, but rather how you use the language to get the best performance and characteristics of your application on this mobile device.
And it can be interesting for you to take a look at the source code of the Android platform itself. So the entire framework is written in Java pretty much. And some pieces of it looks more like C code than Java code. It's very bare bone. We try to avoid, APIs and collections and stuff like that. And it's okay. To be frank, your users don't give a shit whether your code is beautiful or not. What matters is the experience. So again, be mindful, apply those tips in the places that matter. But it's okay to write code that is not the most beautiful code that you've ever written, as long as it serves the purpose of a better user experience.
We can run really quickly through here. I will point out, too, that the link at the top, if you happen to write that down really quickly, we gave a talk 3 years ago, at a conference called Devox in Europe, which is a very good Java-focused developer conference, about memory, basically. We gave a 2-part talk. The first part was about memory, and we gave a lot more data than we're going to give tonight about how much objects cost, how many bytes they take up when you allocate an integer object as opposed to an primitive.
It is a very deeply technical talk, and spoiler alert, it can be pretty boring. It's full of great information, but it's not a high-level talk by any means. You will learn a lot of things about how the Android system behaves, how you can debug memory allocations, how to debug how much memory your IP is actually using, because the information is there, it's available on the device, but it can be pretty difficult to interpret the information. So not the most entertaining talk, but a lot of very valuable information in there.
Totally needed more jokes there. Okay, avoid allocations when possible. This is really about basically not causing thrashing in the GC. In particular, if you're in your onDraw method, don't allocate a new pane object. Instead, keep an instance around that you can reuse when you need to. It's the kind of tip that wouldn't really occur to a traditional Java developer because temporary allocations are cheap. Not so much when they add up over time and cause a GC.
But again, that doesn't mean you should avoid memory allocations everywhere. If you're in the click handler of a button, so it's a discrete action that doesn't take place very often, it's okay to allocate memory. Don't allocate dozens of megabytes, but it's okay to allocate temporary objects there because it's not going to happen often. But in event handling, layout, measurement, drawing, animations, image processing, anything that's going to, inside an inner loop that's going to run very often, avoid allocations as much as possible. And we have a few tools that are available in the IDE and in the SDK that will help you track those allocations. But I think we'll talk more about them at the end of the talk.
Yep. Caching. So one of the techniques that you'll see in the framework code a lot is that we have these static objects or temporary instance objects that we use because why allocate that pane object more than once that you're going to reuse every time through the inner loop, et cetera. Object pools, generally not a good programming practice. In general, people went away from that a few years ago, but if it avoids, if you can work around some of the issues like multi-threaded access to that object, then it can work around some of these issues.
Object pools are interesting because they're not particularly garbage collector friendly, especially with the awesome kind of garbage collectors that you find on servers and on the desktop. Because you keep a lot of objects in memory that you don't need most of the time. But on Android in particular, where a garbage collection pause, even of a couple milliseconds, means that your app can jank during an animation, it's better to pay the cost of that extra allocated memory and that extra work in the garbage collector over a long period of time compared to a bad user experience. Just about caching, there are APIs in the framework that you can use to help you with caching. One of the best APIs you can use in the Android framework is the LRU cache class. So if you do a cache, make sure that it's always capped somehow, like a number of items, the total size in the cache. Just do something to make sure it's not unbounded. And the LRU cache will do that for you. So take a look at it. It's really easy to use. I think it basically works like a hash map. You can just specify the total size of the cache that you want.
There was a talk at Google I/O probably 4 years ago by Jeff Sharkey. Can't remember the title of it, and he used an LRU cache for bitmap caching strategy. So there's a good example in that talk if you want it. Arrays, array list is good in general. It does a little bit more allocation. It needs to reallocate an internal array whenever it resizes itself. So primitive arrays are good to consider as an alternative.
So arrays are interesting, not just because you have a better control over the size of the object. You also have less overhead. Some of the collections in the Java libraries, like the linked hash map or the tree set, have actually a lot of overhead per item. So if you have dozens of thousands of items and you don't store a lot of information in the items, let's say integers or very short strings, the overhead of the collection itself can quickly outgrow your actual data. So you're going to pay a huge cost in terms of memory and garbage collection for something you don't actually need. So arrays, for instance, if you look at the source code of Android, so we have the view group class that manages a list of children. it uses an array of views for the children. It doesn't use an array list. Because one of the benefits of using an array when it's used in a tight loop, like drawing, measuring, handling touch events, is because we don't have to go through the extra layer of APIs of array list. We don't have to call methods. We can use the array directly. And in most cases, like the base collection classes, like array list, are fairly efficient. But there are some surprises out there. For instance, the linked hash map, I was surprised it's just a thin layer of another collection in the Java API. So you pay the cost of an extra layer of abstraction for something you could use directly yourself. So I highly recommend that you look at the source code of some of the basic collections. So the hash set, the tree set, the linked list, they're fairly easy to read. It's very interesting to understand how they work. And for instance, that's how I realized that I will never use the linked hash map directly because it's kind of dumb what it does. I think it's linked hash map. I hope I remembered it right.
I just looked at the time and I realized, given how fast we're going through the presentation, we should be out of here before midnight. So we might start whipping through a little bit faster. So one of the things you'll see in the framework code is methods that take objects and then we mutate the objects internally. So for instance, a typical way to return a rectangular result from passing in a width and height would say, here's a width and a height, and then it gives you back a rect. And in the meantime, we have allocated an object on your behalf. In the framework, it's considered more polite and friendly and memory efficient to actually pass in a rectangle that we will set for you and pass it back. And that gives you the ability to then cache that object and reuse it over time. Primitive types, always prefer primitive types like int, float, over things like integer and capital F float. There's simply more memory taken up by these things. There's also more processing time in terms of accessing the values inside. Sometimes it's unavoidable if you are using some of the traditional collections classes. You have to use these things. But just know that when you are using those things, you're going to be causing auto-boxing and temporary allocations along the way when you interact with them.
And Android actually offers a specialized collection. So typically, the use of integer or capital float comes from the use of primitive types inside a map. And for that, Android provides something called a sparse array. And we have a lot of variations. We have the sparse int array. We have the long sparse long array, the sparse long array. There's a bunch of variations. So if you want to, those are variations on the key and the value that you can put in the map. So prefer those. As long as the number of items you use is fairly small, so maybe 1,000 or a couple thousands of items at most, it will be a lot faster than the hash map. If you use more items than that, the hash map will outperform those collections. Granted that you keep the values inside those collections alive for a long time and you don't suffer a garbage collection.
So that was specifically array map and simple array map that I think it is in support library
support
only?
Library,
Yeah. Be aware of the language. Yeah, so here's a nice one that I learned when I was working on the animation system, that the listeners that we have, I think the view tree observers, we would iterate through them on every single frame and say, are there any listeners? If there are, call the following methods. And the way that we said, are there any listeners, was by using the very handy Java 1.5 syntax for each. Why do they call it for each? It just says for. I don't know. Why did they? I don't get it. I type for each and nothing happens. So anyway, so we would say for, and then we'd allocate. We'd say give me one of these things so I can iterate through the listeners, and usually it would be empty. The list would be empty, and in the meantime, it would allocate an iterator on my behalf. So on every single frame, we were allocating an iterator object that would return nothing because it was an empty list. So it's much better practice to actually avoid the for each loop, for each syntax entirely, or at least do a size check before you ask it to allocate an iterator for you.
There are some collections like a linked list that it's better to use the iterator because if you use the get method with an index, the complexity is n, so it's going to go through the whole list every time to go to the index that you want. So again, be familiar with the collections and how they work and understand the trade-offs that you're making.
And actually, if you have a plain old array, the for each syntax actually does the right thing. So it will not allocate an iterator in that specific instance. But yeah, be aware of what's going on. Enums, this is like one of the favorite watch things in Android where we say things like, please don't use enums. And people say, they're idiots. Enums are so handy. frankly, I don't care if you use enum, specifically in cases where, you use an enum in a specific class because there was a powerful reason to use it or whatever. What we really care about, if you want a performance and memory efficient application, is don't use them everywhere. If you're using them as like a common data structure on every single class, or more importantly, if you're writing a library that other people are using, then you're basically injecting a lot of overhead for not much benefit. Right? Yes, we understand the type safety benefit. There is a way to work around that with annotations. There's an int-def annotation that gives you the kind of type safety that you need, at least in the tools. And it gives you that with much better efficiency than the actual enum classes that, in the memory talk that we gave at Devox, we talk about some of the sizes that come about by using enums. So it's kind of interesting, the overhead there.
Yeah, if I remember correctly, the overhead of an enum is about 1 kilobyte of code. Which has tons of implication on your application and the CPU caches. But again, it depends. If you declare one enum in your application and you use, like, I don't know, in a setter to set a mode or whatever, every once in a while, it's okay. If those enums are generated by, I don't know, like a JSON parser that generates Java code for you and generates hundreds of them, then it starts to be a problem.
Finalizers, here's a fun fact. A finalizer will cause not a GC, but 2 GCs. So the first full GC that it does puts it in a queue where it can be collected on the next GC. So whenever you add a finalizer to your class because, hey, it's convenient, I want to clean up after myself there, only do that if you really need to. We do it in very specific situations in the framework where we need to deallocate an object at the native level, and that's really the only mechanism that we have to do that. But we avoid it like the plague when we can because you're really forcing the garbage collector to, at some point, stop the world and do these 2 collections.
So it's actually one of the reasons why we moved the bitmaps memory back to the Java heap, I think somewhere in Android 3 or 4. 3. It's because we're in situations where the application holds a large number of bitmaps and it knows it's going to run out of memory. So it nulls those bitmaps, there's a garbage collection pass, and then they try to allocate something. Unfortunately, the memory held onto by those bitmaps needed a second GC pass to finalize the native memory. And then you would get an out of memory in between the 2 garbage collection passes. So to make that easier for the applications, we just moved everything to the Java heap. And of course, there are applications out there from large companies that are trying to find workarounds to move the bitmaps back to the native heap, which is going to cause tons of issues, but I won't name names.
Static leaks. So unfortunately, the idea of processes is not the same as the idea of activities on Android, which was kind of a mental shift for me when I first started working on the platform. I think of like the thing that I'm running right now as being the process, and so I would say, well, I need this, this variable to be shared among all things that are actually, running within that activity, and then the user would turn the device, and a new activity would be created. And then I would allocate another one of these static objects, and eventually I'd leak a lot of stuff. So in general, avoid statics because you're leaking stuff. Unless you really want to share that across the entire process or you have an intelligent way to manage that thing to make sure that you're not doing it, it's kind of a bad way to go. Instead, it's much more efficient and safe to actually share things relative to the context that you're actually within instead.
And the leaks can be very subtle.
Yeah.
For instance, if you keep a drawable in a static, let's say you want to build a cache of drawables because you're loading them from disk, and you put that in a static hash map, drawables have a reference back to the last view that they were set on. So that means that by caching those drawables, you will keep the views in memory, you keep the children of those views, you will keep the context. The context is the activity has all the views, it has all your data, and you're going to leak a lot of memory. And it's not a real leak in the sense of native code where you can actually lose access to the objects and you don't even know where they are. So you can always go clear that cache, and I've actually seen applications be very careful about clearing those caches when they're paused or resumed. But in general, if you put something in a static, make sure it's a plain object that doesn't have references back to anything that comes from the Android framework. We actually plugged a number of those memory leaks in Android itself. For instance, the text framework for text views has an object called a text line. It's just a small structure that we use internally to do some computations. And if you put an image or an icon inside a text view, then through the text line, we would leak the entire activity and everything. So it can be very, very easy to leak a lot of memory through statics.
As I know well, because I have done the same. When I was implemented, I think transitions, I needed to keep a map of listeners so that I knew what animations were running in the system. So the listeners tended to be created as anonymous init classes inside whatever code happened to be running at the time. Maybe it was inside a view. So here you have an anonymous init class that has a reference to its bounding class, which was the view instance that it was within. And the view, of course, has a reference to the context, right? So I would store these things, but it was okay because I stored it in a weak hash map. Weak means that, the references are going to be collected, right? No, actually not the way that weak hash map is implemented. Instead, it would keep a hard reference to the listener, which meant indirectly it had a hard reference to the activity. The user rotates the phone, and all of a sudden I have a thing inside this, what I then called leak hash map, that will never go away, right? So basically the transition system was leaking activities every time the configuration changed because of this very problem.
Why did we hire you?
That's not the question. The question is, why am I still working there?
That's a good point.
So one of the things that's not obvious to people, certainly coming from traditional Java programming language backgrounds, is, well, I like this library. I like this dependency injection library called Juice. It's wonderful. It does all this stuff for me that's really necessary. It does it in a way that is not efficient on mobile. It was not written for mobile. It doesn't take some of these constraints, a lot of these constraints, into account. In particular, dependency injection libraries in general use a lot of reflection. Reflection is really horrible in Android because of some of the allocation concerns that we've talked about, as well as runtime overhead. If these libraries were not written for mobile, then they're probably not appropriate for mobile because they're using different patterns of using the language itself. And you're probably dragging in way more code than you want or need in your application. To some extent, libraries like ProGuard can help, but depending on what the dependencies are in that library, they're probably not going to help very much.
Yeah, and it's not just about the allocations. For instance, I know that Guava, depending on which parts of the library, I believe there's a case where you can run into a static initializer that will do a lot of work. I mean, it will measurably slow down the startup of your application just because you're loading one of the Guava classes. So it's something they're aware of. I hope they will fix it at some point. But be very careful when you use third-party libraries that are not meant for mobile. Measure them, profile them, use the tools that we're going to talk about hopefully at the end.
Actually, Dagger is a good example, a good counterexample where first Dagger 1 and then Dagger 2 were written to address some of the concerns on mobile. So if you do want to do a dependency injection, look at things like Dagger 2 that were actually written with Android in mind.
Protobuf is another good one. So we had protobufs for Java. Then we have macro protobufs to make them more efficient on mobile. Then we had nano protobuf, then pico protobuf. At some point, they will reach the singularity, I think, and have no code at all. It seems to me like you should just not use protobufs, but Google would disagree with me.
So I've done a calculation based on the new time. Now we'll be out of here before Tuesday. We're not very good at going fast through this thing. Okay, so one of the mechanisms that we added to Android is trim callback, so we can actually tell you when the system is under memory pressure and you can do something about it. Again, if you're a greedy application, maybe you want to ignore that. On the other hand, you may get killed if you ignore it. If you're holding on to a bunch of stuff that you can actually release and keep running reasonably well, why don't you do that at this time? Because the system is very serious about this.
And the framework actually relies heavily on those callbacks. So when your application usually loses focus or goes in the background, the UI Toolkit will receive one of those callbacks, and we actively trim our internal caches. So we have caches of OpenGL textures, we have font caches, we have mesh caches. We have a lot of things we keep around just in case that we try to get rid of as much as possible when the app goes in the background, so we can lower the memory pressure on your app and make sure you don't get killed. So do the same, otherwise all of our efforts are for nothing. Please.
What's that?
Please.
ISLOREM device is a method you can call to figure out whether you're actually on a limited memory device, which I believe now is 512.
512.
And you can use this to determine, okay, can my application enter into a mode where it is even more memory efficient so that it runs reasonably well on these more constrained devices. Avoiding large heaps. So there is this way that you can request a large heap, and for really media intensive, like super large image or video content applications, maybe that is unavoidable, but it's not a workaround for your bad memory management. If you request a large heap, you're basically dedicating a bunch of the system just to your application, which means you go in the background, maybe launcher has to be restarted because you just took all the memory on the system, and the user hates your application, and then your application is probably going to get killed in the background because it's taking too much.
And to be fair, there are legitimate use cases. That's why the API exists. But before you turn on the large heap, make sure that there are no leaks in your application, or make sure that you can't save memory somewhere else. In 80% of the cases that I've seen, the large heap was not actually necessary. It was just the app was leaking, and the easiest fix was to just request more memory from the system. And that is not a good way to fix your application.
So services run in the background, and they can keep running in the background, but a lot of services don't actually need to do that. So if you just need some temporary things to happen in the background, make sure you stop that service. Or use one of the facilities that's actually not a service running in the background, but it's just something that is spawned up when it's needed and then automatically shuts down.
There's actually something interesting you can do with services, and you can also do it with broadcast receivers. In your manifest, you can disable those things by default. There was the case of the email application on Android. So if you only have a Gmail account, the email application will still start a service because it needed to try to check for your email. So what we did to fix it was we disabled the service, and the service gets enabled by the app. There's an API to enable services. The service was enabled by the app only after you added an email account. So if your application relies on services that don't have to be started all the time, like if you have to be signed in, or if you have to take a certain action before the service is ever needed, make sure you disable it in the manifest, and make sure you enable it like from your code when needed. And the system will remember that the service is enabled. This is safe to disk.
The larger your code size is, the longer it's going to take for your application to download, the longer it's going to take for your application to actually be paged into launch and start. So optimize for code size. Use tools like ProGuard to actually strip out the stuff you don't need. ProGuard is something that people like to avoid as like part of the normal build situation. So a lot of developers would do something like maybe they don't use it on their developer release build or their developer builds, but on their release build they'll run it regularly, which is a good thing. Wow, we're on to the second section. Okay, now we're out of here by Wednesday.
It's going to take even more time.
Wow. Okay. Performance matters. CPUs.
So, we can go through this slide fairly quickly. So there's this misconception when we talk to app developers, and again here I'm talking sometimes internally at Google, where you take the latest device from Samsung, for instance, and you see that it has 8 cores and multiple gigabytes of RAM and a fairly powerful GPU. The thing is, not all those cores are turned on at the same time. When they are turned on, they're not necessarily running at full speed. Most of the time, an Android device will try to run at around 300 hertz. Hertz or megahertz? Megahertz. Yeah, that sounds more reasonable. I wish it was 300 hertz. Because the hardware can do something doesn't mean it actually does it. And especially with the octa-core devices, usually they're split in 2 categories. There's the big cores that are turned on when you're actively using the device, when the screen is on. And then we have the little cores that are used when the screen is off and to run background operations. So don't trust the numbers that you see on the marketing slides. Try to understand what the hardware actually does and how it's being used. And there's also the problem of the thermal envelope. So our CPUs are getting faster, our GPUs are getting faster. What we cannot do, however, is cool your device better than we could last year. So one of the recent CPUs on the market has 8 cores, and every one of them takes about, I think, 1 watt of power. But the total number of watts that a device can sustain, roughly for a phone, is 2 or 3 watts. Beyond that, the device would melt, so the device just reboots to protect itself. So the system never turns on all the cores at the same time. So again, those are not desktop computers. On a desktop, a GPU is fed 300 watts of power. We have 2 watts for the entire device to run everything: the camera, the RAM, the GPU, the CPU, the display. And we don't expect that to get any better anytime soon. So this is the big bottleneck these days. So again, try to target lower-end devices because your high-end device probably behaves in pretty much the same way. What the high-end devices will do is like the same operation is going to be a little faster because we have better instruction sets. The RAM may be a little faster, but that's about it. And speaking of RAM, one of the big issues that has happened over the past 20 years is that our CPUs have gotten a lot faster very quickly. You know, there's the famous Moore's law, but the RAM has not was not able to keep up at the same speed. So RAM latency is really horrible on today's devices. And actually, a lot of optimizations that are done in performance-sensitive code bases, usually it's graphics engines and stuff like that, is not really to optimize the code itself, it's to optimize the memory access. A good example is in C++. If you use virtual methods, so it's the same as in Java. Like in Java, all the methods are virtual. So to resolve a virtual method, the CPU first has to jump to the virtual table, find the address of the actual implementation of the method, then jump to that method. So there's this indirection, and that's causing tons of extra memory access for the CPU. And a few months ago, I read a postmortem from a game developer, and they said that just before shipping their game, they removed all the virtual method calls from their rendering engine, and they improved performance by 40%. So the gains can be huge. And we have, if you guys are interested, maybe I'll post the link on the meetup page. I gave a presentation in France. The slides are in English a few months ago that talks about this in more details. But it's really impressive what you can do by just changing your memory access pattern. You can multiply, your performance by 2, 3, 10x without changing the actual code.
Speaking of Moore's law, one of the misnomers about Moore's law is that you assume, well, by the time we ship this application, especially since software always slips and it's going to be really late, the devices are going to be that much faster. So I don't really need to worry about the performance problems on my particular device or on this lower end device, because we'll have new devices next year, 2 years, 3 years. One of the things about Moore's law is not only does it make well, not the law itself, the underlying actual principle is that, yes, devices are getting faster, but those are the high-end devices that companies are pushing every year and selling every year. On the other hand, the other devices are, A, still being owned and used for years after they were bought, and B, still being sold. Because just because we have the technology to create the higher-end devices doesn't mean that these other devices, these lower-end form factors, aren't still viable. In particular, what Moore's law does is make those devices cheaper, which means that in countries and locations in the world where maybe people aren't buying the high-end phones, they are buying the phones that you thought were dead 4 years ago. So yes, it matters this year, but it's also going to matter in 3 years when your product finally ships that was supposed to ship in 3 months.
For instance, the Nexus 4, which was one of the high-end devices, 3 years ago, something like that, the hardware that's inside the Nexus 4 is now the cheapest hardware you can buy from Qualcomm if you want to build your own phone. So that's what goes in the cheap phones. Again, what was the high end is now the low end. The good news is that if you keep your devices, you can easily test for the low end market by just using the phone that you left in the drawer for a couple of years.
Dalvik versus Art. So Art did a lot of things with the garbage collector and the runtime to optimize things. It's much better. It does not fix all the problems that we're talking about. It makes them better. So the GC pauses went down from 20 milliseconds on average, maybe down to 4 to 5 milliseconds. But that's still a significant amount of time for a GC pause that you want to avoid. So all the same things apply to Art, but they also still apply to Dalvik, which is still out there as the runtime on KitKat and below.
And there are other reasons to test your applications both on Art and Dalvik. For instance, in particular, with Art, the garbage collector is now a moving collector. So when your application goes in the background for enough time, it will move the memory around to compact your heap. Dalvik never did that. So what could happen, and in the talk we reference on parlys.com, we actually show an example. I wrote a small application that causes this problem, where I was allocating memory in a way that with 90 megabytes of free RAM in my heap, a 2 megabyte allocation would fail and the program would crash because the memory was fragmented in such ways that there was not a single chunk of 2 megabytes contiguous memory available in the heap. So if your application is working on Art, you might be running out of memory on Dalvik just because of fragmentation. For most applications, it's not going to be a big issue, but if you deal with large data structures, like maybe a game written in Java, or if you manipulate bitmaps, you do image processing, audio processing, you should really try to test on Dalvik as well.
Wouldn't it be nice if your application came up quickly? So one of the things that we would stress to application developers is make it launch really quickly. Even if that means you are deferring some work that's going to be done later, at least present something to the user as quickly as possible. We're going to talk about this later, or we would if we got to it, but I'm pretty sure we're going to kill the talk before we get there. There is a concept in Android called the starting window, where the system will automatically launch a blank window with your theme that you've declared in your manifest. And it'll do that really quickly. Like within 200 or 300 milliseconds, that starting window is staring at the user in the face. And that's really good because they've seen some immediate interaction with the device that something is happening. But in the meantime, if your application is taking 4 seconds to launch, then they're staring at a very boring UI. Wouldn't it be nice if you actually could come up with at least the rudiments of your UI for them to interact with in the meantime?
So to give you an idea, when we launched Android 1.0, I was working on the launcher application, and the goal was to do a cold start of launcher in less than 500 milliseconds. So launcher was heavily multi-threaded to be able to load all those icons and all the apps in the background and present, at least the wallpaper and the All Apps button as fast as possible. And be very careful when you benchmark the launch time of your application, because you want to make sure that your process is not lingering around, because otherwise it will be a warm start where your process is already there. Because we fork process from Zygotes. From the Zygote process, there's a lot of pre-initialization that's done for you. So the only way you can truly test the cold start case is to actually make sure from ADB that you kill the whole process and that it's not in memory anymore before you start the application. So I'm sure a lot of you are familiar with this slide. So avoid any kind of hard work in any of those parts of the UI framework. So animations, input handling, measurement, layout. Don't allocate. Don't decode bitmaps. Don't do network access. Don't do disk access. Don't do anything really, please. Just don't run any code. That's the best thing you can do. And we understand that sometimes, it's easy to just put some of the work inside those methods, but it's already hard enough to stay to run at 60 FPS, especially when you have to deal with garbage collection and CPU throttling and that kind of stuff. Just do yourself a favor and just don't put code in any of those things.
Or if you need code to be run when those things happen, just run it on a separate thread. That's what async task and these other utilities exist for, so that you're not at least causing a synchronous stall right in the middle of trying to get through the next frame on the UI thread.
Although on the topic of multi-threading, something I forgot to mention earlier that's also interesting. So I was talking about CPUs and the way that we don't always run them at full speed. So something fun that can happen on multi-core processors is that, let's say your application is running, nobody else is running, so your threads are chugging along on one CPU, everything's running fast, and suddenly something in the background happens, and we need to wake up a second core to be able to do all the work. So what the scheduler will do, it might migrate one of your threads from the current core to that new core that just came online. The problem is that new core is not running at full speed yet. Maybe it's running at 300 megahertz when you're running at 2 gigahertz, and suddenly one of your threads will get slower just because a new core came online. And your threads might bounce back and forth between different cores. The core might get turned off. So sometimes you might see performance degradations when something else in the background shows up, or when you start a new thread. And the best tool to be aware of those problems is systrace. We'll mention it later.
We will. In fact, I think what we're going to end up doing with this talk, which is going way long, is to kill out the last half of it, but then skip to the tools slides, because I think that's useful.
It's funny how we always kill the section of the talk that we know nothing about, like network and
I don't know
content
how
providers.
that happened. Be scrappy. So if you don't need views or containers, don't use them. The complexity in your view layout translates directly to the amount of time that we're going to spend actually processing that layout. If you don't need it there, don't put it there because it's more convenient than inflating it later or whatever. You are causing more overhead for us just to walk up and down the tree for doing things like view invalidation or layout or just figuring out where things are on the screen for input or whatever. So avoid that when you can. Also, there's a lot of, what's that?
I want to.
You want to talk about the second one? There's a lot of confusion about the second one, and part of it is blamed on you.
No, it's blamed on my manager, whose code I had to maintain. It's my personal nemesis. So, have you ever used relative layout? Raise your hand if you have used relative layout. Okay, so first of all, I'm so sorry for you.
Second of all,
bad developer.
Second of all, everyone in here that's ever used Android Studio has used relative layout because they decided to give you relative layout by default at the top of your hierarchy.
So relative layout has one tiny problem when it comes to performance. It has to measure every child twice. And that's not that big of a deal if your relative layout is a list item. The problem is when the relative layout is the root of your whole UI, and inside that relative layout you put another relative layout, then the children of the second one will be measured 4 times. And then if you put another relative layout in that relative layout, you see how it goes. And we've actually seen applications that were spending, in the hundreds of milliseconds doing layouts. It was not really their fault. They didn't know. It was mostly our fault because relative layout is dumb. But just try to use something else if you put a relative layout fairly high up in your tree. So in KitKat, we actually made a fairly big optimization that helps relative layout a lot. We try to remember the last measurements, and we try to actually not rerun the measurement code if it's the same as last time. And so that has gotten a lot better in KitKat. But if you measure on old devices, you'll see that it can be pretty bad. So if you can easily replace your relative layouts with something else, and that those relative layouts are towards the top of the tree, please do so. If it's at the bottom, if it's in a list view item, if it's the last few views of the tree, don't worry about it. It's okay.
Or if you need it, like it is there because it is a powerful, it is the most flexible layout that we have. It exists for a reason. It's the reason that Android Studio uses it is the only applicable layout that allows you to do the correct constraints between children that you need in a lot of cases.
There's an alternative called grid layout. I highly suggest you take a look at it. It can be a little difficult to use at first. I highly recommend you use a pen and paper to understand what you're doing. It's basically grid-based, but it's a flexible grid. Read the documentation, read the samples, you'll understand. And I think we gave a talk at Devox. So there's on parlays.com. There should be a talk, if they recorded it, that explains how to use it. Anyway, there's also another layout that can do bad things to your UI. It's a linear layout. So if you set a weight on a child of the linear layout, that child will be measured twice as well. So if your root view is a linear layout and inside you have a child that has a weight and that child itself has other linear layouts and relative layouts, you'll be in the same situation. So again, make sure to profile your applications to see if you're spending too much time doing layouts.
The algorithm's so nice, we ran it twice.
We want to make sure we get the right result.
Test on low-end devices. So the one that you're carrying in your pocket is way better than the one that most of your users have. So make sure that you test with that. And also test with older devices. In fact, I know a lot of developers that use that as their primary device or have that at least as their primary test device, is something much older that is more representative of the market out there than your budget allows for.
I wish we could give everybody the Google Doc Food applications. So what happens when we put our corporate account on our phone, Google automatically sends us like every day or two updates for all the Google apps. So that's what we call dog fooding. And so those apps are always kind of in flux. And the result is that your high-end device is kind of like a low-end device. We should have a channel on Play Store for that. Make my device suck.
So instead of talking about networking,
because we don't understand networking.
Language and libraries is pretty interesting.
Because we understand it.
A little bit. Serialization is horrible. It was really a disk format, way too much
By
overhead.
Serialization, we mean the Java serialization API, so the serializable interface. It's hard to use anyway for a number of reasons, and on Android, we didn't try to make it fast and efficient. Don't use it, do your own.
We talked about the Android data structures like array map and simple array map. XML and JSON, again, a lot of overhead unless you actually need to interact with some web services returning XML. Probably a more efficient data structure for you to use. Avoid JNI. For one thing, you have to compile native code to all the architectures your code is going to run on. Also, there's a lot of overhead. It's actually fairly expensive calling down to JNI or calling back up from it. So it's usually not a good way to do things. If you need faster computation than the language will give you, you might consider things like RenderScript, which I guess some companies do. So the RenderScript compute exists to basically address that problem, like really intensive, fast stuff. It can even be farmed out to multiple cores and GPUs, but it avoids the problems that we mentioned with JNI. We mentioned primitives and autoboxing before. Let's skip storage. Let's skip framework. We'll talk quickly about UI performance. You want to talk about Overdraw?
Sure. How many of you are aware of what Overdraw is?
Me. Ask me.
Okay, that's not enough. So Overdraw is the act of, you draw something on screen and then you draw something else on top of what you've just drawn. This is extremely common when you work on UIs because pretty much every view is semi-transparent. There's always, anti-aliasing in the borders. You have drop shadows. So that's perfectly normal and expected. The problem is, especially given the screen densities that we have to deal with today, My device in my pocket has the same number of pixels as my 50-inch TV at home, which is ridiculous. And the Nexus 6 has the same number of pixels as my 30-inch display on my Mac Pro. And yet, we're trying to drive those displays with those tiny CPUs and GPUs. And the problem is that we do not have the memory bandwidth to draw a lot of pixels. So the more you overdraw, the slower the device will get. And there's actually a hard limit. Our bus has a certain capacity. And typically on Android, if inside your application you overdraw by a factor of more than 2x, you're going to start losing performance really fast. And the degradation, it's more of a cliff. So everything is fine, and you're running at 60 hertz, and suddenly you draw an extra pixel, and you're going to go like this. And that's bad. So we have built a tool to detect overdraw. So if you go into developer settings, there's a checkbox or combo box, I don't remember. It will paint the screen in different colors depending on how many times you've touched those areas of the screen. And if the colors if it's red, you definitely need to do something about it. Especially if you see a lot of red, you really should do something about it. But if you want to know more, we're not going to go into details here. I wrote an article called Android Performance Case Study, where I talk a lot more in details about overdraw, what it is, how you can solve it, what tools you can use to address it. So make sure to run your app through that tool. It's on your device. You can do it right now. You don't even need a computer to run the tool. And make sure your application is correct.
So one of the workarounds that developers sometimes use for overdraw problems that they see is null window background. So a typical cause of overdraw is that a theme will, by default, have a background on the window, right? So, and this is so that when the starting window comes up, hey, we have something to paint there. It looks a little more reasonable than not painting anything. So you have a background there, and then maybe like your top-level container is a list view with an opaque background that contains items that occupy the entire list, and then all of a sudden you have like 3x overdraw before you've drawn a lick of text, right? You're drawing the window background, then the background of the list view container, then the items themselves, and you're at 3x. Like, well, what do you do now? So the developers are like, well, obviously you eliminate the window background, so we'll get that out of the way. If you do that, weird things happen, like, well, then the starting window will come up and maybe draw black on some architectures, maybe draw artifacts.
So that's only if you remove the background in the theme.
In the theme, right. So yeah, there are good and bad ways to do this. The correct way to do it is in your activity on create method, then you say set window background to null. But that still has some artifacts that you can run into in situations where maybe the keyboard animates up and your window contents automatically got resized. And again, the window manager would really like to draw something there, and you've told it not to. And so you can get some sort of weird graphics artifacts. A better approach is to actually keep your window background, but eliminate the opaque background in the containers that are on top of it. Instead, just use that window background as the background for the things that are sitting on top of it.
So the good news is that as of KitKat, the rendering pipeline will try to detect and remove as much overdraw as possible on your behalf, but that's only possible when you draw something opaque on top of something else. And like I said, most of the time, the elements that sit on top of the UI in the top layers are translucent in some way. And in that case, we cannot remove what's behind it. So sometimes we need you to do the work.
We mentioned the starting window before. Some applications will disable the starting window because they want their own custom splash experience. There are a couple of problems with that. One is that the starting window is able to start immediately, and if you actually need to do things like load a bunch of bitmaps and custom information just to come up with your custom splash experience or your first UI, then you're basically disabling that experience where the user got to see some immediate response from tapping on your launch icon.
You can actually use the theme for the preview. You can change the theme of the preview window. And in one of the first versions of Google Maps, that's what we did. We gave the preview window a background that looked like, when Google Maps cannot load all the tiles, you see just a grid of empty gray space. And that's what we used as the background of the startup window. So it felt like the app was already there, but it was totally not loaded yet. So that's a good way to do it if it fits your theme and your UI and all that. So don't try to, work around it. If it doesn't work, it doesn't work. Don't worry about it.
It can even be a custom drawable. So you could actually come up with a customized splash screen experience by using the starting window. It doesn't have to just be a solid color. Actually, the best, and by that I mean worst launch experiences where applications decided to go ahead and keep the starting window, I think because they didn't know what they were doing, because they also had a splash experience. So they had a startup window come up with the default theme, not the theme that they were using in their activity, So they had some window coming up looking like something. Then I had a splash experience coming up with this custom green window drawable thing. And then a couple of seconds later, the application came up looking completely different. So now the user got to see their application launched 3 times.
There's a name for that. It's called a game.
Yeah.
Most game, when you launch them, when you exit them, you'll see the gingerbread style window because they want to be gingerbread compatible, and they didn't bother just setting a black background to their preview window to get rid of the ugly gingerbread window. So I really need to go talk to some game developers.
Interaction. What time are we? You know what? What time do we have to go to? Because we're trying to. Yeah. Okay. So we're going to talk about tools, and then we'll be done. Tools. Hey, there they are. There are 2 categories that we think of for tools. There's the tools that you actually run on the machine, the host device. So you're going to type this stuff into your laptop, desktop, interact over ADB to launch these tools, get the information on the host.
Just Leak Canary is not a host tool. I don't know why we put it on that
I don't. And in fact, that's the only tool that we don't provide. It's just that we were playing with it this week, so we put it there. It's kind of nice. Okay, systrace, we mentioned this already. A lot of improvements in the latest preview release. Please check out systrace. It tells you what's going on in the entire device.
How many of you have used systrace before? All right, it's more than I expected. That's good. The systrace is awesome because it's a profiler, kind of like TraceView, but it gives you an overview of the entire system. So the nice thing about systrace is when you see that something is slow in your application, it will show you on what CPU your threads are running, whether your threads are running, and what is the frequency of the CPU. You can also correlate the information in systrace with other processes. So sometimes it's useful. You can understand that your process was slow because some other process was blocking you or whatever. Look up the documentation. We gave a couple talks where we introduced systrace. I think we gave a talk at Google I/O in 2012, maybe. You can find the video online. We talk more in details about systrace.
Actually, the greatest thing about the new things that they added to it are that they're trying to make it actually easier to understand. The downside to systrace is there is a lot of information in there, and it's not obvious to the outside developer or even the inside developer exactly what's going on and what you're supposed to do about it. There's tips built into the UI now where it'll flag things like, there's a little red F circle there, meaning your frame went over the 16 millisecond boundary. You can click on it and it'll tell you why that is. Application tracker. I think this is my personal favorite tool because I used it to chase a lot of the bad things that were happening when I was first working with the animations, like the iterators that were being allocated on my behalf because of the for each syntax. So find out when and why and where you're allocating memory along the fly. It's a good thing to know. Trace view, this has 2 modes. It runs either in sampling mode or method profiling, where it'll show you everything that's going on. Method profiling has a lot of overhead, so don't pay attention to the times that it's telling you, but the relative times are an interesting indicator of what's going on in your application. Hierarchy viewer was written by you.
A long time ago.
So you can run that to sort of see what's going on in your application, what your view structure looks like. It's a good way to spot things like an overly complex view hierarchy. Mat is the Eclipse tool that you can use. You can take an hprof dump, convert that, and then run it in Mat to see where the leaks are coming from. But there's a new tool out there that's a very low overhead tool to use called Leak Canary. You can find it on GitHub. It's from Pierre-Yves from Square. And it's code that you can inject into your application to basically tell you when you've just leaked a particular lifecycle tracked object, like an activity or a fragment.
The nice thing is, so you add the library to your application, and when you leak an object, you will get a notification in the status bar, and when you tap on it, it will show you the stack trace that led to the leak, so you'll know exactly what object has leaked and why.
Memory monitor. There are new memory tracking facilities coming out in Android Studio, so check those out. And on the device side.
So strict mode is an API that you can use from within your application. You can set what are the strict mode violations. So for instance, you can enable all of them or only some of them. So if you enable all of them and you do disk I/O on the main thread, if you do network access on the main thread, things like that, you will get either an exception or a log, or the screen will flash red. You can decide what is the reporting policy. So that is extremely useful. If you've never used that API, you should take a look, because it's a very easy way for you to find out performance bugs in your application by just use your application on a day-to-day basis, and when it flashes red, you know something wrong happened. GPU overdraw, we talked about it. GPU profiling is also available from the developer settings. If you turn that on, we will draw a performance graph on top of your application. and there's a little green bar, a horizontal green bar, and then you have a bunch of vertical bars. If one of the vertical bar crosses the green bar, that means your application is not running at 60 FPS. So that's also a good and cheap way to check that your animations or your scrolling is always running at 60 FPS. If it doesn't, then you'll have to go to other tools like the GPU overdraw, to systrace, to trace, to figure out exactly what is going on. But at least you'll know it's the drawing that's wrong.
Another setting in developer options is duration scale. I use this a lot for chasing bugs in animations. You can basically say, run this at 10x, and then you can see things happen slower for the 3 different kinds of animations that we have on the system. A way more useful tool I found is something that came online in, I don't know, L or KitKat, probably, screen record, A2B shell screen record. Give it a file location, and it'll record everything going on in the screen. And then you can upload that MP4 to your desktop and frame step it and see what actually happened during that animation that was too quick for you to catch in real time.
You can invoke screen record from Android Studio. There's a button, so you just click start, then you click stop, and it will give you a video of the device.
But it's way more fun to type the command line.
And hardware layer updates, yeah. So hardware layer updates, if you turn that on, I won't go in details about hardware layer updates. I wrote an article about this on my blog online. You should go read that. But basically, if you update hardware layers too often, that's going to be a huge performance bottleneck. So when you turn that option on, every time we update a layer, it will flash. I think it flashes green.
It does. It turns your phone Irish.
Yeah. So yeah, turn that on. If your application keeps flashing, you're doing something wrong. Go read the article. If nothing flashes, just forget about it. And actually now, I think we report that as well in the new systrace. So we'll insert a marker in the timeline that will tell you when you've updated a hardware layer.
And now, oh my God, we're done. This is a short link to the Developing for Android articles. It starts out with an intro and then goes on and on and on and on and on from there. So check that out on medium.com. We have probably limited time for questions, but we'd be happy to take them as long as we can. Thanks.
She doesn't want questions. Sure.
It's all right. We didn't have anything to say about them anyway.
Don't do network access, and do not store anything.
The presentation is not. The presentation is new, but all of that information, except for the random anecdotes, is all what the articles are. Yeah.
Yeah, in the article. So the article has actually a lot more information, links to the documentation, to other articles. So yeah, go read they're on Medium. Okay, perfect. Yep. So go read that. And also, if you just look up our names in Android performance, you'll find we gave half a dozen talks over the past few years on that topic. Well, we explain in more details, all the tools we mentioned, all the primes we mentioned, and some others. So you might find some valuable information in there as well. You'll find them on the Google I/O channel.
Or Google Developers channel, I think.
Google Developer channel.
Posts all the I/O talks. A lot of the talks that we've given are on parlays.com. because they post all the talks from Devox. Actually, I wrote a blog where I linked to all the interesting performance talks because they were getting scattered over the years. So if you go to my blog, one of the latest entries from a few months ago is, so it's codedependent.blogspot.com. Code-dependent.
It is, but when it's been 10 years that you know, it gets old. It's okay, I still love you.
Awkward. Yes. I heard that.
Those guys put a lot of great open source software fragments across a lot of weird bugs. What are Google developers' thoughts on encouraging use of that library? But also be a good idea to say,
diversity is great. If you like fragments, you can use fragments. If you don't like fragments, you don't have to use fragments.
So actually, I do a podcast whenever I get around to it, and we talked to one of the folks from Square this week, the guy that wrote a lot of Leak Canary, and he was saying, oh yeah, so I have some thoughts on fragments. I'm like, I don't really want to talk about that on the podcast because frankly, I don't use fragments. So I'm sure there are really good reasons to. I'm not the person to actually get into that conversation because I'm more on the plumbing side and a different part of it.
Well, so more seriously, what we've seen is that it's always an issue when we mention best practices because people tend to follow them as hard rules, and that's all they are. They are best practices, and again, you have to apply them differently depending on the situation. And there are some cases where fragments, you shouldn't use fragments because they don't give you anything. So if your application is not on tablets, maybe you don't need fragments. If you don't reuse a chunk of your UI across portrait and landscape on a tablet, maybe you don't need fragments. So it really depends on the application. And a lot of applications will never need fragments. And of course, yeah, if you use fragments everywhere religiously, you'll run into problems because they add a lot of overhead to the development cycle. But at the same time, I don't believe it's also correct to say I will never use fragments no matter what, because they're part of an ecosystem, and someone will have to maintain your code someday. And the more you come up with your own framework and your own way of doing things, the more difficult it will be for others to join your team, maintain your code, read your code. And I don't know about you, but I read code a lot more than I write code. And it's not just because I'm a manager, because that's what we do as engineers. So keep that in mind. But there are some bad APIs on Android, and you should avoid them. So if fragments really don't work for you, don't use them. But again, it's a decision you make, based on your app. Examples of media codec and media server? No.
Sorry, no. Nope.
I've seen a couple samples on d.android.com. They're probably the ones you're referring to, but that's about it. Sorry, not my area of expertise. All right, so yes, so if you get a surface from the media codec or media server and you do log canvas, it crashes. So log canvas is one of our ancient APIs from back when Android was not hardware accelerated, and not all surfaces will support non-hardware accelerated rendering or access, because the memory might be in places that the rendering library Skia, the canvas, can access. So usually locking the canvas to get a canvas is a bad idea because you're going to run in software and it's going to be really slow. So if you want to draw on a surface, what you should do is use OpenGL instead. That should always work. So if you use anything other than GL Scissor, it draws fine, but GL Scissor doesn't draw anything. It's a clip. No, you're supposed to draw on the surface. I've done it a bunch of times. So I don't know about this particular case. Maybe OpenGL can be finicky, so maybe the problem lies somewhere else. Mm-hmm. So GL Surface View, are there restrictions outside of GL Surface View? GL Surface View is just a utility library. It doesn't do anything you cannot do yourself. So I don't know what the problem is. I would have to see the code to get an idea of what's going on.
We should probably move on. I'm thinking most people aren't doing GL Surface View
everybody
stuff.
cares about OpenGL, okay?
Maybe if you can catch us afterwards. Thanks.
So you have your images compressed on disk, but when you draw them, you want them to use less memory. So the only way we could do that would be to use texture compression on the GPU, which opens a huge can of worms. And there's the only thing you can do is to use the 565 format. So it's 16 bits per pixel. It is slower, and the quality is not good. So it can work for some type of images like clip art, stuff like that. But for photos, you're going to see a lot of bending, dithering, noise. And we really recommend you stick with ARGB 888.
The problem you're running into is the size that it occupies on disk actually has nothing to do with the size it's going to occupy in memory, because when you create that bitmap, it is going to be width times height times depth, period. Right? So even if it was highly compressed on disk, it doesn't matter. It's still going to be the size that it needs to be to occupy that memory. It's not encoded. It is a bitmap that is width times height
So
times
if
depth.
you want to change the way the bitmap is decoded, when you load a bitmap using the bitmap factory, you can pass a structure called options, and you can specify the format you want out of it. So there you can say that you want 565, which is going to take half of the space. But again, it's going to look bad. 4444, so you probably never used it, because if you had used it, you would know that it's a terrible idea. It looks like crap, to the point that it's actually deprecated, and I believe that we're removing support for it. And actually what the hardware acceleration pipeline does is, no matter what format you're using in your Java bitmaps, we convert them back to 888 anyway, because that's what the GPU wants. So yeah, 565s, but you should avoid that.
Also, reuse your bitmaps using, again, bitmap factory options. You can. So one of the problems people run into with bitmaps is not necessarily on any particular bitmap, but the fact that they run out of memory eventually, because that one needs to be deallocated. Then they allocate another one. They're thrashing GC, performance problems, memory problems. What you should do is use a field called in bitmap to say reuse this cache of mine, especially if you're like running through a bunch of thumbnails and you just want to use like these common things, then go ahead and decode the new ones into the cache that you have instead. There was a question over here earlier. No? Yeah.
So the question is it okay to have white assets, your PNGs, so that you can tint them? So is it a good idea? So it is a very good idea. And it depends how you tint them. If you tint them using the paint, so on the paint you can use an extra mode and a color to tint a drawable. Or if you use the new APIs that are available in Android L, it's extremely GPU friendly. The GPU will only basically take the pixel from your image, multiply it by the tint color. It's super cheap on the GPU. It's not going to cause allocation. It's not going to do any churn. So it's a really good way of minimizing the number of assets you're using. And that's basically what material design does all over the place.
Yeah, that was sort of the whole point behind the assets for material design, was take it back to a neutral white and be able to tint it at runtime, so that you didn't have like all these assets for all these different activity states of your application in these different separate colors. Instead, just have them be white and then tint them.
And the nice thing is, even in old versions of Android, so Lollipop makes it a lot easier, but tinting works on older versions of Android. It might be a little more involved. You might have to go get the paint of the drawable yourself, but it's completely doable.
Yes, sir. Yes. So the question was about not stalling the UI thread. In this particular case, you're using sensors instead, but there's the same advice of basically not doing that really heavy computation in the middle of receiving that event. The general idea in UI thread as well as this is, well, I have a chunk of work to do. Let's make sure that my UI can reflect some intermediate state while I go off and do that work, and then it comes back later when it's done. It can come back with incremental progress, which async task offers, or it can come back when it's finally finished, and then we can update the UI or the information in the application accordingly. Async task is one utility. Loaders are also used. I don't know if there's another one that we recommend.
Well, and then in the Java standard libraries, there's the java.util.concurrent package with the executors and the thread pools. There's a lot of good stuff in there.
There are gotchas with async tasks that I've heard people talk about when we recommend those. That
and by talk, you mean complain?
Maybe. If you make too many assumptions about let's say, the liveness of things when you're actually called back later. So if there was a configuration change and the activity was torn down and the view went away, and then you get a callback to this thing, or just other changes in the state of your application that may invalidate some of the assumptions that you're making in that async task, you want to be aware of that. But in general, basically, yeah, these utilities exist for offloading it onto a separate thread and then updating your application state later. Oh, yeah.
I think there was a question in the back.
Yeah. Okay.
So you had an issue where you have a drawable, you tint it programmatically, and you have to. And so what happens? Yeah. So the next time the drawable is used, it will have the same tint, and you have to mutate it. Yes, it's exactly why the mutate API was created. So the rule of thumb, it's actually fairly simple. Any property of a drawable that you can set from XML is going to be shared by all the instances of that drawable. So if you have a drawable in XML that's, I don't know, like a circle, and then you do a get resource that, get drawable 10 times. If you go change the tint on any one of them, all 10 of them will get the tint. That's because when you do get drawable, we don't reload the drawable every time. We have a cache of those drawables. And when you mutate, what you tell the framework is, please make a copy of the state because I'm going to change it for that instance. So that's the right way to do it. There are some properties of drawables that don't need to be mutated, but in general, what you can do is you can just call mutate just to be safe. And what happens is that if you call mutate twice, the system is smart enough that the second mutate is a no-op. So feel free to just call mutate every time you change the drawable.
So that functionality is intentionable. Intention. Yes, question. What I heard was, wow, bitmaps are really confusing.
And they are.
Is that the essence?
One thing I want to mention. Thank you. Bitmap recycling is not a thing anymore. Basically, calling bitmap.recycle has no effect on recent APIs, and since 3.0, I mean, it's not going to do you any good. Bitmap reuse was very limited in the first versions that it was introduced because Chet was lazy. So the bitmap had to be the same size and the same config and all that. But recently, I don't know if it was L or KitKat.
I think it was KitKat.
Yeah. So in KitKat, basically, if the bitmap you're using reusing is large enough, can hold all the memory of what you're decoding, then it's just going to work, no matter what the configuration is, the resolution is. So what you can do in that case, you can even pre-allocate a bitmap that's big enough for all your needs, like ahead of time, and then always use that bitmap. Now, if you need to work across multiple versions of the API, and you not support Android 3 and 4 and all that, it's hard, and we're extremely sorry about that. And you have to have different caching policies for those different versions. It's extremely unfortunate, but it's the kind of problems that we've only been able to discover as people were using the system in the platform. And if we could go back in time and fix it, we definitely would. But
we're totally working on that time machine. I probably shouldn't have mentioned that. Actually, another thing worth mentioning is the existence of libraries for caching. Like, a lot of this stuff is really complicated to do, and fortunately, there are other people thinking about this problem besides the people just working on the plumbing libraries.
There's
Glide,
there's Glide, Picasso from Square. There's Fresco from Facebook. And others. They do a lot more too, like they do a bit of processing and stuff like that.
There's also Volley, that's more about network transactions. It does some amount of bitmaps. I don't think it has like super involved bitmap caching strategy stuff. But yeah, the other ones we mentioned are probably a little closer to what you'd want. Well, so the question was, if you're using LRU cache with bitmaps, you don't need to worry about recycling. Bitmap.recycle, yeah, it's a no-op as of 3.0, as soon as we moved it up to the Java heap.
Yeah, and even before, bitmap.recycle was a bit finicky because there was kind of like automatic, like manual memory management at the native level from Java, and it leads to a host of bugs, and especially if you do asynchronous operations or if you're using third-party libraries in your code that have an async task pending that's trying to touch the bitmap, you're going to get a crash. So recycle was never a good way of managing bitmaps, which is why we moved everything to the Java heap to get rid of the need of recycle.
It allowed you to manually manage your memory, but it then required you to manage that memory, and it's a bit much to expect everyone to manually do it correctly. So the Java VM does it for you instead. Any other questions? Yes.
One quick question on creational patterns. What is the overhead for certain builders or prototype factories on?
The question is, what is the overhead of factories, builders, and prototype patterns? The overhead is just going to be the extra objects that you allocate. But usually, maybe not factories, but builders are usually transient objects, and you create them when you're about to allocate another object anyway. So I think they're fine. It's more about make sure you don't allocate in places where you shouldn't allocate. But if it's a place where you can allocate, whether or not you allocate, 16 bytes or 40 bytes, it doesn't really matter. But again, be careful, measure, use allocation tracker, all that.
I think the hook is coming out, and we're getting yanked off stage.
Question, then if we got more, we can just talk after.
Awesome. Okay, one more question.
Sorry?
Yes, please.
Async task has been the number of threads.
Well, first of all, two things on that. So async task, the number of threads in the pool has been changing. First of all, it's my fault, so I'm deeply sorry. Secondly, it's your fault because you guys use the API in ways that I definitely did not imagine you would use it. It was never intended to be used as a thread pool with a lot of threads, a lot of tasks pending. And so that's why we changed the policy. Then we had issues when we moved to multiple cores. We discovered that apps were making wrong assumptions about the order of execution of async tasks because they're part of a thread pool, so there's absolutely no guaranteed order of execution, which is also why they moved from a parallel pool to a serialized pool. So currently, I think we haven't changed the number of threads in async tasks since 4 point something, so it's pretty stable now. The default pool is serialized. So if you know what you're doing, if you need a lot of threads, and by a lot I mean more than like half a dozen, create your own thread pool, use the executor API from java.util.concurrent. You'll have a lot more control over what's going on. And if you look at the source code of async task, all it does is wrap around. I mean, there's some clever things in there because concurrency is hard, but it only wraps the executor service, the executor and the thread pool. That's all it does. There's nothing that you cannot do. You can even copy the code in your app and just copy paste the code in your app. It's open source. Put it in your app. Change the number of threads you want, and that's it. Like done. That's the beauty of Android. Like if there's something you don't like just put it in your app and compile it yourself when it's possible.
Thanks.